Because we are working with inequalities in two variables, our solution sets will be represented on the graph. The inequalities can take on the following forms. To graph an inequality in two variables, we start by graphing the boundary line. This is found by replacing the inequality with an equal sign. It is called the boundary line since it will divide the graph into two pieces and provide a boundary to the solution set. If the inequality is greater than or less than, no equals to, the line is dashed to say not also the points on the line. If you have the or equal to part as well, then use a solid line to say include the points on the line. The next step is determining which half of the real number plane represents the solutions. You can use a test point to figure this out. If a point is picked above the line, substituted into the inequality, and provides a true statement, then all the points above the line are solutions. Therefore, you would shade this upper half. The points below the line would then provide, we'd find, false statements. If you should happen to get a false statement, you will always shade then the other half, the opposite half. Here's our first linear inequality. Again, the solution set will be drawn on the graph. We start by graphing the boundary line. This is found by replacing the greater than or equal to with just an equals. Because of the arrangement of this boundary line, I'm going to graph the line using the x and the y intercepts. Again, with the greater than or equal to part included with your inequality, draw in a solid line. Next, we try and figure out which half plane, above or below the line, represents the solutions. Using the origin 0, 0, which is clearly below the line, plug it into the inequality, we get a false statement. Therefore, we shade the area above the line. The shaded area represents the solutions. Here's our second example. Start with the boundary line, which is x equals 3. Recall that this is going to give us a vertical line. This line is going to be drawn with a dashed line due to the just less than. Interpret this inequality this way. Where are the points on the graph with x coordinates less than 3? Is it to the left or the right of this line? Well, the x coordinates less than 3 will be to the left of this line, or as in the previous example, if you wanted, you could go back to that test point. We're now moving on to graphing a system of linear inequalities in two variables. We will graph both of these inequalities on the same graph. The solution to the system will be where the two separate solution sets intersect. If one inequality uses a yellow shading and the other uses a blue shading, you'd be asking yourself, where does yellow and blue make green? The green will be your solution set, solution to the system. The boundary lines are found by replacing the inequalities with the equal sign. Again, I use the x and y intercepts as my 2 points to graph the lines. This is not your only method of graphing the boundary lines, but personally I think in this case it's the easiest. We need to differentiate between the two inequalities, so as you can see, I'm going to draw one red and the other blue. One inequality has a greater than or equal to, therefore this line is solid. The other has just a less than. This line will need to be dashed. Next, we need to figure out which half plane to select between these two inequalities. Again, using the origin 0, 0 as our test point, 0, 0 is above the blue line and provides a false statement. Therefore, we will shade below that line. 0, 0 provides a true statement in the equation for the red line, that inequality, and it's below the line, therefore we shade below that line. We will draw in these two shaded areas and then look where the shaded areas intersect. The purple area is the solution to the system, since that is where the two colors, two shaded areas come together. Hopefully this has been helpful. Thanks for listening.